is our physics lab testing the relationship between speed and distance and how long it takes objects rolling at different speeds at different inclines to slow down by they reach the end of the camera's viewpoint. Our observations that inspired us to do the lab are that cars that are speeding only a little bit go much farther before stopping when they brake. And that inspires us to test this exponential relationship. Our question is, how quickly does a round object slow down when rolling at different speeds? Our hypothesis is that objects would take exponentially longer to slow when they are going faster. Because of the car demo that Mr. Cross so kindly showed us and the fact that speed overrides friction from the ground. Our independent variable is the speed at the beginning of the camera's view and the dependent variable is the speed at the end of the camera's view. Our constants were the type of floor, temperature of room, object, scale, etc. Our materials were a round object, a ramp, the floor, a video camera which we used an iPhone, vernier lager pro, a chair and a meter stick. Our procedure is to roll the object down the ramp and repeat 10 times for different inclines and analyze the data. Here is an example of our experiment from one of our tests. Table with time. Y is the position and Y velocity is how fast it was going. Here's our graphs. The third one is kind of messed up because of an error with some points being way too high. Unfortunately, it was hard to draw a conclusion from the data because we forgot to take the scale and the idea of slowing down didn't work out so well. I believe the data is exponential, but I'm not sure. Our conclusion is that if objects roll across the floor at different speeds, then the faster ones will take exponentially longer to slow because the extra speed overrides friction. The YouTube video that Mr. Cross showed us depicts that. We don't really have enough evidence to know that, but I still think our hypothesis is correct based on the evidence we have. On the first trial, the speed of the rolling object was approximately 1 meter per second. On the second trial, the speed was approximately 1.7 meters per second with more of an incline throughout the camera's view. With this knowledge, we can easily say that the distance it takes for the object to stop is greater when the speed increases. There were a few errors in our experiment. Our idea of measuring speed at the beginning and end of the camera's range didn't work out so well because the speed did not change much at all. Because there was a fire drill and that we didn't realize we had to do at least 5 trials, we didn't get enough data. The iPhone camcorder kept on wanting to change the way it would record from horizontally to vertically, so the positive and negatives may have been wrong. Inertia takes a lot of energy to overrule because of how much friction it takes to stop the object from moving quickly. We came up with 2 questions following this experiment. Would it be possible to stop light? And what is the true power of inertia? And how inert really are objects? Here are our group members and what they did.